Today, I'm happy to share our project, Improving UI Generation Models from Designer Feedback. This is work that I did with my collaborators at Apple, Amanda, Arun, Alan, Jeff, and Titus. So I think this cartoon represents an increasingly common scenario in HCI, where experts like designers work on products and systems where behind the scenes they're powered by AI models. And of course, one example would be designing a chat-based agent or bot. Or it can be a scenario where the AI is integrated into powering some component of a system. And in this paper, we looked at generative UI, which is one example of this scenario where you have an application that uses AI to generate on-demand interfaces. And in all of these cases, there's a question of how does the designer get the AI to do what we want? In the case of Gen UI, models can sometimes make mistakes like the design defects you see in my attempted Kai website. And even if it looks good, designers need to give their input for various constraints like company branding and make decisions regarding trade-offs. So today, some options we have are prompting, using something like RAG for context engineering, or trying to make the scaffold better. But those strategies can only get you so far past what the underlying model can do. And besides waiting for the next ChatGPT to come out, I think it makes a lot of sense for designers to pull back the curtain and use their really rich knowledge about design, users, and a specific application to improve the model itself. A good place to start when thinking about this goal is a technique called reinforcement learning from human feedback, or RLHF. And there are many variations of this, but I'll describe one of the most common methods. And let's say you have a base LLM that you want to improve on a specific task. The first step is to sample the model's output by repeatedly generating multiple responses for a set of prompts relevant to that task. Next, human labelers are asked to rank or rate these candidate responses, and these comparisons are used to train what's called a reward model. The reward model is able to assign a score for anything the model generates, where the score is a surrogate for the rank that the human gave it. And if you have an accurate reward model, you can use it as a training objective to improve the base LLM, where if you maximize the score, in theory, you would also be maximizing human satisfaction. Well, in practice, this depends on many things, but one big factor is how accurate your reward model is, which is ultimately decided by the feedback data that you have. If you've used ChatGPT enough, maybe you've encountered this Easter egg which will ask you to choose which of two responses you like better. And this is really the standard approach for RLHF because you can see how it aligns with the reward modeling formulation. But when we tried to apply this to UI designs, we found really high levels of noise and disagreement due to the subjectivity of the task. And designers also later told us that they didn't want to spend all day responding to these kinds of queries. So in this project, instead of using a feedback interface designed around the modeling requirements, we wanted to design feedback interfaces for designers. And we started by looking at the interactions and workflows that they're already doing in their job. So in the literature, we identified 3 common interactions. So there's commenting with natural language, which is like writing to-dos or giving feedback. There's also sketching, which in our case, we equated to a grounded form of feedback. And then finally, there's revision, which is opening that design file in an editor and actually changing things around to make it better. And our work is aimed at collecting this natural interaction data and converting it into a form that can be used by machine learning. Okay, so we developed a couple of conditions for comparison. First was the baseline, which was this ranking interface that compares 2 rendered UIs. And training the reward model is quite straightforward. You just train it to assign a higher score to the chosen screen and a lower score to the rejected screen. We also developed a commenting interface. So here we only showed one rendered UI at a time, and designers could enter a list of comments in the text field. And for training a reward model, we first got another LLM to take the original UI's code and try and address the list of comments entered by designers to generate an improved UI. Then we made sure that the score of the improved UI was higher than the score of the original UI. Sketching was similar, but the main difference was that before writing a comment, designers could use these drawing tools to annotate the screenshot. And this turned out to help trace the part of the code that designers wished to improve. And then finally, we had the revision condition. So here we converted LLM output code into a sketch file and asked designers to open that design up in the sketch editor and actually try and make it better within some time limit. And then we assigned a higher score to the UI after the version of the UI after it's been edited by the designer. So you might ask, which feedback interface leads to the best data? And to answer this question, we performed a data collection with 21 professional designers. Our study took 60 minutes in total, where in addition to some onboarding, they had around 10 minutes to use each feedback approach to label as many UIs as possible. In terms of data quantity, across all conditions, we had 1,500 samples, and 1,000 of those was from ranking, so that was definitely a majority. And this makes sense because you can click A or B very quickly compared to actually performing those revisions. But what about quality? And to measure that, we had researchers inspect the labels generated from each type of feedback. And we asked them to see if they agreed that the higher scoring one was indeed better. And here we found almost the opposite ordering, where revision data had the best quality. So in other words, after designers were given a chance to improve the UI, we tended to agree that it actually did improve. But does better data actually lead to a better model? And how should we reason about this trade-off between quantity and quality? So we performed a second experiment where we first trained different reward models using each type of feedback. Then we used those reward models to fine-tune the same base LLM, QuenCoder 2.5. When we conducted an arena-style evaluation to see how those fine-tuned models compared against each other and some baselines, we found that sketching and revision data was the most effective, with sketch feedback being rated the best on average. Okay, then following this study, we wondered, well, how generalizable are the designer-trained reward models? Because in our experiments, designers only gave feedback on outputs from a specific model, QuenCoder 2.5. So maybe the feedback from designers were only focused on things that particular model was good or bad at. Well, lucky for us, over the course of our project, Qwen released at least 2 more new models. So we got to test this hypothesis on the smaller Qwen 2.5 3 billion model, and also Qwen 3, which was a model with a new architecture. And we just used the best performing sketch reward model from the last study. After conducting a similar arena-style evaluation, we found that incorporating designer feedback always led to significant improvements regardless of the base LLM. And also, our best fine-tuned model was rated even better than GPT-5, which is likely several orders of magnitude larger in size. Our paper has some more qualitative outputs, but here's one example where you can compare the before and after of our training process, and also compare it with baselines like GPT-5. Okay, so to wrap up, let's get back to this cartoon. In this paper, we introduced an approach where designers can directly train UI generation models. We developed a pipeline where LLM code was rendered and presented to designers for feedback. Then their feedback was used as training signal for model improvement. Besides showing that designers can contribute to model improvements through a process that we called reinforcement learning from designer feedback, we show that the level of improvement is much higher than traditional RLHF ranking. We also showed that designer feedback collected on one fixed set of UIs can, in a sense, be encoded and reused to evaluate and improve other models too. Our work has implications for both HCI and machine learning. For example, in this paper, we only attempted to adapt a few methodologies used by designers, but we think in the future many more can be bridged. More generally, I think we should look for ways that HCI experts can not only use, but also help develop better AI. Finally, I just want to add that we have open sourced our models and dataset for this paper, so please check it out.